In this video, we're going to look first at step number 4 of writing Lewis structures. Step number 4, we're going to add the remaining electrons in pairs. And that's very important. The remaining electrons should always go in pairs to complete the octets. And we're looking at every single one of these atoms as trying to get 8 valence electrons, with the exception of hydrogen. Hydrogen only wants 2 valence electrons. The reason that hydrogen only wants 2 valence electrons is when we look at the periodic table, hydrogen is in energy level number 1, principal quantum number 1, and that first principal quantum number can only hold 2 electrons. So energy level 1 is full with 2 electrons. So hydrogen only wants 2 valence electrons. We're also, remember, we figured out the total electrons that we're putting in, so we have to keep taking off as we put in pairs. And we're going to complete the octets on the terminal atoms first. Those are on the outside. We are completing the octets on the outside atoms first. Then we work toward the middle. And that's important. Complete the octets on the outside atoms first. And then we work towards the middle. So let's take a look and see what this is going to look like for these examples. The first one, we have C connected to 4 H's. Each one of these bonds represents 2 valence electrons. And when we calculated how many electrons we still need to put into this molecule, there were 0. We don't have any more, and here's why. Carbon in the middle, this counts as 2 electrons for carbon, these 2 shared electrons from the covalent bond. This counts as 2, this counts as 2, this counts as 2. So this carbon is sharing 8 valence electrons. And that's what it wants. It wants 8 valence electrons. So it's complete, it's full. Now take a look at this hydrogen. This hydrogen's sharing 2 valence electrons through the covalent bond. Well, where's the other 6 electrons going to come from for hydrogen? Well, remember, H only wants 2 electrons because it's in energy level 1 and it's full with 2 electrons. So as long as H has these 2, this H thinks these 2 belong to it. Carbon thinks these 2 belong to it. They're sharing those 2 electrons. Same thing with these 2 electrons, these 2 electrons, and these 2 electrons. So this hydrogen has 2 electrons being shared. This hydrogen has 2 electrons being shared. This hydrogen has 2 electrons being shared. It's complete. It's done. Now let's take a look at HCCH. Now we've got 4 electrons still to put in, and we're always supposed to put them in pairs. So we start on the outside atoms. The outside atoms are hydrogen, so they already have 2 electrons being shared. This hydrogen has these 2. This hydrogen has these 2. Hydrogen does not want any more electrons. So what I'm going to do is I'm going to go to the inner atoms, and I'm going to put a pair of atoms here, a pair of electrons here, and a pair of electrons here. Now this carbon has 2 electrons from this bond, 2 electrons from this bond, and a pair. It thinks it has 6 electrons. This carbon has 2 electrons here, 2 electrons here, and this pair. So it thinks it has 6 valence electrons. We know that we're wanting to get to 8, but at this point, we can't do anything about it. That'll be the next step. Then Xe with 1, 2, 3, 4, 5, 6. 6 connections. 6 connections to F. So we have an F, 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 and F. Now, we have 38 electrons to put in. We know we have to put them in pairs, and we always complete them on the outside atoms first to get to 8. So this F right here has 2 valence electrons from this bond. It wants 2, 4, 6 more in pairs. We call these lone pairs of electrons. We always put them in pairs. So this F now has 2 electrons from the bond, and then 2, 4, 6 from the lone pairs. That gives it 8. So we move over to this F, and we put 2 on it. It already has 2. Now it has 4, 6, 8. It's done. I'm completing. I'm adding the remaining electrons in pairs. I'm adding these remaining electrons in pairs to complete the octets of the terminal atoms, the outside atoms first. This F has 2 valence electrons from this bond, and now we go 2, 4, 6, 2 more make 8. I add in 2, I add in 4, I add in 6. It already has 2, that gives it 8. I've added in 6, 12, 18, 24. I can add in a total of 38. So then we go 2, 4, 6. Now it has 8. 2, 4, 6. Now it has 8. The bond counts as 2, and then each lone pair that I'm adding in then pairs. We go to the outside atoms first. So I've used 6 times 6, 36 electrons. I have 2 more electrons to go. What do? We put those electrons on the outside atoms first, then go to the center. So somewhere I add in a pair of electrons on Xe. Now, when I look at Xe, I know something's wrong. Xe in the middle, 2 for the bond, 2 for the bond, 2 for the bond. So 2, 4, 6, 8, 10, 12, plus another 2. On Xe, there's 14 electrons. That is an exception to the rule. It should only want 8, but it's an exception to the rule. Xe should not want to bond anyway because it's a noble gas. So it's got more than 8 valence electrons. So now we look at H, C, N. We've got 6 electrons to put in. The H does not want any more because H only wants 2 electrons because it's an energy level 1 full with 2 electrons. So we're not putting any electrons there. Then we got to put them on carbon or nitrogen, but we want to complete them on the outside atoms first. So nitrogen already has 2 valence electrons from this bond. So I put another 2 electrons here. Now it has 2 from the bond and 2 from the lone pair. That gives it 4. So I put 2 more on it. Now it's got 2 from the bond, 2, 4, so a total of 6. I still need to put 2 more electrons in because I put 2, 4, but I'm supposed to put 6 in. So I put another 2 right there. Now nitrogen with the bond 2, lone pair 2, lone pair 2, lone pair 2. It now has 8 valence electrons. So it's done. But I've put in all 6 electrons. Carbon only has 4, so it does not have its 8 valence electrons, but we're going to find out that what we have to do in the next step. So we go to carbon with 2 oxygens. We've got 12 electrons to put in. And now we start on the outside. Oxygen already has 2 from the bond. So I put 2 more, 2 more, 2 more. Now it has 2 from the bond, 2, 4, 6, 8. It's complete. I've put in 6 electrons for the remaining. So I go to the other side. I put in 2, 4, 6, and then with the bond makes 8. So I put in 2, 4, 6 electrons, 2, 4, 6 electrons. That gives me my 12 total electrons. Oxygen has 8 valence electrons, 2 for the bond, 3 lone pairs. Oxygen has 8 valence electrons, 2 for the bond, 3 lone pairs. The carbon we don't know yet. because it only has 2 electrons here and 2 electrons here. Finally, the last example, Sb with F's on the end. So it'll be similar to our Xe example above. We have 30 electrons to put in. So this F has 2 electrons from this bond with Sb. So now I'm going to put 2, 4, 6 more electrons in. Now it has 8. So I've used up 6 of the 30. Then I go 2, 4, 6 with the bond makes 8. Then I go 2, 4, 6 with the bond makes 8. I've used up 6, 12, 18. 2, 4, 6 with the bond makes 8. 2, 4, 6 with the bond makes 8. And I've used up 6, 12, 18, 24, 30 electrons. So this molecule is done. Finally, our last step is if there are not enough electrons, our final step for Lewis structure, step number 5, if there are not enough electrons to complete the octet on the central atom, bring in pairs of electrons from an attached atom to share with the central until it has an octet. So we are going to create double or triple bonds. We are going to create double or triple bonds if needed. Notice this all begins with if. If we don't have an octet on the central atom. So let's take a look here. There's nothing to do here. This molecule is done. Carbon in the middle has 2, 4, 6, 8. Each hydrogen has 2. No double or triple bond needed. Now, let's take a look at this example. On this example, we do need a double or triple bond, and the reason being, hydrogen's okay, it's got 2. Hydrogen's okay, it's got 2. But this carbon only has 2, 4, 6. This carbon only has 2, 4, 6. So what does it say to do? If there's not enough electrons to complete the octet, 8, on the central atom, bring in pairs. So I'm going to take and I'm going to bring in a pair of electrons to form another bond. When I do that, take a look at this carbon. It now has 2, 4, 6, 8. But this carbon only has 2, 4, 6. So we're going to need to take this pair and also bring it in. And now both of them, as you will see when I rewrite this, H, C, triple bond C, H. Now, both groups, all atoms, have 8 valence electrons. This hydrogen has 2. This carbon has 2, 4, 6, 8. This carbon has 2, 4, 6, 8. And this hydrogen has 2. So we brought them in until they all had 8 valence electrons. The next example, Xe, already has too many electrons. It's got 2, 4, 6, 8, 10, 12, 14. So it's already an exception to the rule. We don't need to do anything. Let's take a look at this next example. This hydrogen has 2 valence electrons, so it's done. This nitrogen has 2, 4, 6, 8, so it's done, but this carbon only has 1, 2, 4. So we need to bring in another pair of electrons. So we take a pair and we bring them in. Remember our rule, this 2 electrons now turns into a bond. Remember, each one of these bonds we know is already 2 valence electrons. So these 2 electrons slide in and make a bond just like these 2 electrons. And these 2 electrons, and these 2 electrons. So now, whoops, I moved into the next problem, and I apologize. So we take a pair of electrons and we move them in. Now we look at carbon. Carbon has 2 valence electrons, 2 valence electrons, 2 valence electrons, all from the bonds, 6 valence electrons. So we need to move another pair in to make 8 valence electrons on carbon. Hydrogen has 2 valence electrons, so it's done. Carbon has 2, 4, 6, 8 valence electrons. Nitrogen has these lone pair plus 2, 4, 6. That gives it 8. When I rewrite this molecule, it looks like HC triple bond N. And all of these atoms with a lone pair. Don't forget the lone pair. All of these atoms have 8 valence electrons. Now, when I go to carbon dioxide, this oxygen already has 2, 4, 6, plus the bond is 8. I previously counted 2, 4, 6 with the bond makes 8, but this carbon only has 2, 4 electrons. So I accidentally, when I was circling these, moving them in, I accidentally circled these and moved them in. So I moved those in. Now carbon has 2 for the bond, 2 for the bond, 2 for the bond, 6. But the next group I move in, I'm actually going to move in from the other oxygen, because in our very first step, we talked about this process. Many molecules tend to be symmetrical, so we want to keep things symmetrical. Now take a look at this. There's 2, 4, 6, 8. This oxygen has 2, 4, 6, 8, and this oxygen has 2, 4, 6, 8. So we end up with oxygen double bonded to carbon, double bonded to oxygen, and then a pair, 2 pair on that oxygen, and 2 pair on that oxygen. And then finally SB, 2, 4, 6, 8, 10. It's also an exception to the rule. So over here, I'm going to put exception to octet rule for Xe, and also exception to octet rule for SB. Both of those are exceptions to the octet rule because each atom really only wants 8 valence electrons, and they have more than 8 valence electrons. I hope this helps with understanding the 5 steps of the Lewis structures for covalent molecules.